Next, we're going to look at a problem where we need to reduce a fraction. Let's reduce 72/90ths to lowest terms. Now, to accomplish this, we're going to take 72 and 90, and we're going to rewrite them in a factored format. One thing you may note at the beginning is we're looking for really the greatest common divisor of both. Well, 72 and 90 might be numbers that you're familiar with. For instance, when we look at 90, it's pretty easy to see that's 10 times 9. 72 can also be written as a multiple of 9. That's 8 times 9. So at first glance, this is what you may see. But it turns out that as we look at the 8 and the 10, we may note there's another common factor that we might be able to deal with, and that is a factor of 2. So I'm going to rewrite this as 4 times 2 times 9, and in my denominator, 5 times 2 times 9. Now, to reduce means to divide out common factors. So we're going to divide the numerator by 9 and the denominator by 9, divide the numerator by 2 and the denominator by 2, and that's going to give us our result of 4/5 as our reduced format. Now we're going to look at converting a mixed number to an improper fraction. Convert 2 5/8 to an improper fraction. Well, to do so, what we're going to do is notice that 2 5/8 can be rewritten as follows. We're going to take our value of 2 and we're going to multiply it times 8, put this in the numerator with an addition of 5 all over 8. A lot of times you'll see people converting by moving their hand in this direction. The 2 is multiplied times the 8 and then add the 5. This is going to give us 16 plus 5 divided by 8, and now adding 16 to 5 gives us 21/8 as the improper fraction. In this example, we're going to go opposite to our last example. That is, we're going to start with an improper fraction and go to a mixed number. Convert 5/3 to a mixed number. We're going to rewrite 5/3, and we're going to note that 5 is equivalent to 3 plus 2. We choose 3 because we look at the denominator. We're then going to break up the two add-ins in our numerator, divide each by the denominator. That'll be 3/3 plus 2/3, and that's going to give us 1 plus 2/3, which can be rewritten as a mixed number 1 2/3. Now let's look at rewriting fractions. In fact, what we want to do is take each fraction, each rational number, and rewrite it as a decimal. To do so, let's remember that the fraction bar can be thought of as a division symbol. So 3/8 can be thought of as 3 divided by 8. To change this to a decimal, we note the decimal point after the 3 and we add a 0. We're now going to go directly above the decimal point and put it into our quotient. And we're going to have 8 into 30. That's going to go 3 times. 8 times 3 is going to give us 24. And let's subtract. We get 6. We add a 0 and bring down a 0. 8 into 60 is going to go 7 times. 8 times 7 is 56. Subtract. We get a 4. That's not finished, so we add a 0, bring down a 0. 8 into 40 goes 5 times. Multiply gives us 40. And now we have a remainder of 0. So what we can see is that we have a terminating decimal, and 3/8 is equivalent to the decimal 0.357, or red, this would be tenths, hundredths, thousandths, so that's 375 thousandths. Now let's look at part B, where we have 5/11ths, and do the same type of process. We're going to take our 5 and divide by 11. 5 cannot be divided by 11 in its present format. We're going to put our decimal point, bring it into our quotient. 11 goes into 50 4 times. Multiplying gives us 44. Subtracting gives us a 6. Add a 0, bring down the 0. 11 into 60 goes 5 times. Multiplying gives us 55. Subtract, we get a 5. And we notice at this point that we would have the same division once more. So once we start this repetition, seeing that our remainder here is the same as what we started with, we're going to notice that we would continue getting the 4, 5, 4, 5, 4, 5 over and over again. We'll write this in a decimal format by putting a bar over the repeating portion. And so our decimal format is 0.45 with a bar over the 4, 5. Here's another problem dealing with rational numbers. Express each terminating decimal as a quotient of integers reduced to lowest terms. Quotient of integers really means that what we're doing is writing this in fractional format, and we want to reduce those fractions to their lowest terms. If we'll begin by just saying the decimal name for this number, that will help us. When we read this, we see 9/10. Now, this is in lowest terms, so that's going to be the quotient of integers that we're being asked to write down. For part B, we read this as 86/100ths and write it in its fractional format. Now, you may note that this is not going to be reduced. We can see that we can divide the numerator by 2. We'll have 43 times 2. And we can divide the denominator by 2. We could have 50 times 2 as our factorization. Dividing by that value of 2 is going to give us 43 over 50 as our reduced format. And finally, we see that we have tenths, hundredths, thousandths. This will be 53 thousandths. Now, 53 is a prime number and therefore, and does not divide into 1,000, and therefore this is its reduced format. Here's another problem dealing with rational numbers. Express 0.2, where the 2 repeats, as a quotient of integers. Now, in this case, we're not going to just be able to write this as 2/10, because it's not just 2/10. In fact, remember, this means that the 2 repeats forever. Instead, we're going to use the following algebraic process. We're going to begin by letting x equal our number that's given. Next, we notice that there's one decimal that's going to be repeating, one decimal place. So we're going to multiply this equation, both sides of the equation, by 10. We're going to choose the power of 10 that corresponds to the number of decimals repeating. We're going to write then 10x, which would be the left-hand side of the equation multiplied by 10, equals, and on this side, when we multiply by 10, remember that what happens is we move the decimal place one spot. So this would equal 2.2, but because it repeats, it continues on. So we have 2, 2, 2, 2, 2, continued on. We're going to draw a line under here and subtract the equations from each other. Now, on the left-hand side, we have 10x minus, remember there's a 1 here, 1x, and that's going to be 9x. On the right-hand side, the repeating parts of 2 will all subtract out, leaving us with the value 2. And now, algebraically, we can take this equation and divide both sides of the equation by 9, and that gives us x equals 2/9 as our result. Here's another problem dealing with rational numbers. Express 0.79, where the 79 repeats, as a quotient of integers. We'll begin by letting x equal the number as given. We note that there are 2 decimal places where we have a repeating portion. We're going to take the power of 10 that corresponds, that is 10 squared or 100, and multiply both sides of the equation by 100. We'll write that result above the given equation. So 100 times x is 100x. 100 times 0.79 repeating is going to move the decimal place 2 places, which would give us the value 79. And then because we continue repeating, we have the 79 continuing on. We're now going to subtract vertically. 100x minus, remember this is a 1x, is going to be 99x. 79.79 repeating minus 0.79 repeating, the repeating part is going to subtract out continuously forever, and it leaves us with 79. And so dividing both sides of this equation by 99 will give us our result for x. So x equals 79 over 99. And remember, we had set up x to equal our given number to begin with, so here is the quotient of integers that corresponds. Now let's look at multiplication of fractional values. Multiply. If possible, reduce the product to its lowest terms. We're going to multiply two fractions together by multiplying the numerators and multiplying the denominators. So this becomes 4 times 2 in my numerator and 11 times 3 in my denominator. 4 times 2 is 8, 11 times 3 is 33, and this is reduced as much as possible. In my next example, we have a negative times a negative. We can evaluate that to start with by recognizing our product will be positive. Then we're going to, in our numerator, come up with 3 times 14. In our denominator, 7 times 4. Now 3 times 14 is 42. 7 times 4 is 28. Next, what we may note is that we can rewrite this as 14 times 3 over, and we can rewrite 28 as 14 times 2. Now we see the greatest common divisor of 14. We can divide both numerator and denominator by 14 to give us our value of 3/2. Now we have two mixed numbers multiplied together. We're going to start by changing each mixed number into its improper fractional form. And you'll recall that that process requires us to multiply the denominator times the number 3, in this case 5 times 3, and then add 2. So we're going to rewrite our first number as 5 times 3 is 15 plus 2 is 17. That'll be 17/5. And then we're going to multiply that times 1 1/2 would be 2 times 1 is 2 plus 1 is 3. Now our product will be 17 times 3 over 5 times 2. 17 times 3 is going to be 51. 5 times 2 is 10. And this is reduced as much as possible. What we could do here is go back to mixed number format if requested to do so. Our next problems deal with division of fractional values. Divide. If possible, reduce the product to its lowest terms. We're going to note that when we do division of fractions, we're going to change that into multiplication by the reciprocal. So we're going to rewrite our first example as 9/11 multiplied times 4/3. Now, we're going to do something a little bit different here in that when we're multiplying, we're going to go ahead and look for our common factors as we go before we multiply out. In other words, at this point, I note that we're going to have a 3 in the denominator and a factor of 3 in the numerator, in that 9 is 3 times 3. I'm going to divide my denominator by 3, divide my numerator by 3, and now notice that there are no other common factors, so now I can rewrite this as 3 times 4 over 11 times 1, and we end up with 12/11 as our result. Next, let's look at our second example. We have a negative 8/15 divided by 2/5. We're going to rewrite this as negative 8/15 multiplied times 5/2. Let's look for common factors. First of all, we may note that there's a common factor of 5. 5 divides 5 once, 5 divides 15 3 times. We also note a common factor of 2. 2 divides 2 once, 2 divides 8 4 times. Rewriting, we have a negative in front. We have 4 times 1 in the numerator, 3 times 1 in the denominator, and this result is negative 4/3. Finally, we have an example with mixed numbers. We're going to start by rewriting each mixed number as an improper fraction. 8 times 3 will be 24. 24 plus 3 is 27. So our first number can be rewritten as 27/8. We're going to divide that by 2 1/4. 4 times 2 is 8, plus 1 is 9. And so we have now 27/8 divided by 9/4. We'll change this into a multiplication. 27/8 multiplied times 4/9. And now let's look for common factors. We notice that 9 can divide the denominator and the numerator. 4 can divide the numerator and the denominator. And now we have 3 times 1 in the numerator, 2 times 1 in the denominator to give us our result of 3/2. Next, we're going to look at addition of fractions. Perform the indicated operations. We have in our first example 5/12 plus 3/12. This is going to be equal to 5 plus 3 over 12, since we have the same denominator. We add numerators. This gives us 8/12. We can then note that we have a common factor of 4. We can divide the numerator by 4 to give us 2, the denominator by 4 to give us 3, and our result is 2/3. In our second example, we have 7/4 minus 1/4. Again, a common denominator. We're going to be able to take our numerators and combine them with the operation in between is subtraction, 7 minus 1, over the common denominator. That gives us 6/4. We note that there's a common factor of 2. 2 divides 4 twice, 2 divides 6 3 times, and our result is 3/2. Finally, our example dealing with mixed numbers, we're going to begin by changing this into an addition of a negative. Since we have a subtraction here, a subtraction of a negative, we're going to have a negative 3/8, negative 3 3/8. We're going to change that to addition of the negative of what we have in parentheses, which would be an addition of positive 1 1/8. And now let's change these into their improper fraction format. Our first one will be a negative. We'll have 8 times 3, which is 24, plus 3, which is 27. The second one, we have 8 times 1 is 8, plus 1 is 9. Now we have the same denominator, so we can combine numerators. We have negative 27. We're going to pull that negative sign up with the 27, plus 9. It's divided by 8. Negative 27 plus 9 is going to be negative 18. And now we notice a common factor of 2. We can divide 8 by 2 to give us 4, divide negative 18 by 2 to give us negative 9, and our result is negative 9/4. For our next problem, we're going to look at an addition of fractions where our denominators are not the same. Find the sum of 1/5 plus 3/4. To add two fractions, we need to be working with like denominators so that we can think of these as actually being like terms. It's hard to add 1/5 to 3/4 when they don't have the same units. So we're going to look for the least common multiple of our denominators. In this case, the least common multiple of 5 and 4 will equal the product of 5 and 4, which is 20. Now we're going to take each fraction and change it to an equivalent format where the denominator is 20. To do so, we notice that if we take 1/5, in order to get a denominator of 20, we need to multiply the denominator by 4. Well, to keep it equivalent, we have to multiply the numerator by 4. And that would give us a fraction of 4/20. We're going to do a similar process with 3/4. We have our fraction of 3/4. We want a denominator of 20. To accomplish that, we'd have to multiply the denominator by 5, but to keep it equivalent, we have to multiply the numerator by 5. Multiplying those fractions together gives us 15/20. Now that we have like denominators, we can simply add the numerators to give us 19/20 as our sum. Next, we're going to look at a subtraction of two fractions with unlike denominators. Perform the indicated operation, 3/10 minus 7/12. When our denominators are not alike, we need to come up with a like denominator by picking up the least common multiple of our two denominators. To come up with the least common multiple of these two denominators, there are a number of ways we can proceed. One is to just start looking at multiples of the largest denominator. For instance, multiples of 12. We're looking for multiples of 12 that would be divisible by 10. So we can run through 12, 24, 36, 48, 60, and we notice that 60 is also a multiple of 10. Now we're going to change each fraction into an equivalent fraction with a denominator of 60. So we notice that 3/10, we'd have to multiply the denominator by 6, and so we multiply the numerator by 6 to give us our fraction of 18 over 60. For 7/12, we're going to have to multiply the denominator by 5, and so the numerator by 5 also, to give us 35 over 60. And now we're subtracting the numerators because we have like denominator. 18 minus 35, and that can be thought of as 18 plus a negative 35. That result is going to be negative 17 over 60, and that cannot be reduced any further. In the next problem, we're going to evaluate an expression by using order of operations. Here we have the quantity negative 1/2 squared minus the difference 7/10 minus 8/15 squared multiplied times negative 18. To begin the problem, we're going to work within the set of parentheses, and so we notice that we're going to have to subtract fractions. To do so, we need a common denominator. Our denominators are 10 and 15. The least common denominator will be 30. So what I'm going to do is repeat everything in the problem and then work within the parentheses in order to evaluate this difference. We'll need a common denominator of 30 for each fraction. To accomplish this with 7/10, we notice that we multiply 10 times 3 to get 30, so we'll multiply our numerator 7 times 3 to give us 21. For the second fraction, we multiply our denominator 15 times 2 to give us 30, and so we multiply 8 times 2, which gives us 16. So now we have equivalent fractions with the common denominator. Let's go ahead and repeat the rest of the problem. We can now perform the subtraction in our next step. We have negative 1/2 squared minus, we have 21/30 minus 16/30. That's going to give us a difference of 5/30. That quantity will be squared, and we multiply times negative 18. Now, instead of squaring it in this present format, notice that we can reduce first. So, again, I'm going to repeat the other portions of the problem, and we're going to reduce 5/30 to 1/6. Now, in order of operations, the next thing we want to do is to evaluate our exponential expressions. We notice we have negative 1/2 squared. We also have 1/6 squared. Let's go ahead and do that. Negative 1/2 multiplied times itself. Well, a negative times a negative is a positive. 1/2 times 1/2 is going to give us 1/4. We can now take 1/6 and square it. That's going to give us 1 squared, which is 1, over 6 squared, which is 36. And now we're multiplying that times negative 18. We notice now we have two operations. We have a subtraction here, and we have a multiplication as indicated by the set of parentheses. What we want to do is go ahead and do the multiplication prior to doing the subtraction. And so we can go ahead and multiply 1/36 times negative 18 by thinking of negative 18 as being negative 18 over 1. We also notice we have a common factor of 18. 18 divides into 18 one time, so therefore negative 18 divided by 18 is going to give us negative 1. And if we if we divide 36 by 18, we end up getting a 2. Let's go ahead and write down that result. We're going to have our 1/4 minus, we're going to end up with a negative 1 times 1, which is going to give us negative 1, divided by 2 times 1, which is 2. Now what we need to do to finish the problem is to do the subtraction. Let's go ahead and rewrite this. We have 1/4 minus a negative 1/2. Well, we know that when we subtract a negative, that's the same as adding the positive. So this ends up being 1/4 plus 1/2. We now need a common denominator of 4. 1/4 plus 1/2 is the same as 2/4, which gives us our final result of 3/4. Now we're going to look at another problem dealing with rational numbers. Find a rational number halfway between 1/3 and 1/2. Now, to find numbers midway between two given numbers, we're really thinking about finding an average. And you may recall that to do that with whole numbers, you would add them together and divide by 2. Well, division by 2 is the same as multiplication by 1/2. So we're going to accomplish that with our fractions by taking 1/2 and multiplying that times the sum of 1/3 and 1/2. We'll begin by working within the parentheses. To add the two fractions, we're going to come up with a common denominator. Our least common denominator will end up being the least common multiple of 3 and 2, which is 6. We're going to rewrite each fraction so that it has a denominator of 6. 3 times 2 would give us 6, so 1 times 2 will give us 2. 2 times 3 would give us 6, so 1 times 3 will give us 3. And so inside the parentheses now, we have two fractions with a common denominator. We can add the numerators to give us 5 over that denominator of 6. To multiply fractions, we multiply numerators. 1 times 5 will give us 5, and multiply denominators. 2 times 6 will give us 12. 5/12 is the rational number halfway between 1/3 and 1/2. Now let's look at the following word problem. A chocolate chip cookie recipe for 5 dozen cookies requires 2 eggs. If you want to make 7 dozen cookies, exactly how many eggs are needed? Let's solve that first, and then we're going to round the answer to a realistic number that would not involve fractional parts of an egg. We're going to notice that we're going to have a ratio of 5 dozen cookies to 2 eggs. And the question is, we need an equivalence where we're going to have instead 7 dozen cookies, and we need to determine how many eggs. Now we're going to drop the units and work with 5/2 equals 7 over an unknown value. To accomplish this, we can use a process where we're going to multiply both sides of the equation by the denominator that we see written. That is, we're going to multiply this side by 2 times x, and we're going to multiply this side by 2 times x. Now, the 2's will cancel, leaving us with 5 times x, and on the right-hand side, the x will cancel, leaving us with 7 times 2, or 14. We can now notice that 5 times a number equals 14. To solve for that number, we're going to divide both sides of the equation by our value of 5. And we're going to have x equals 14/5. Now, if we change this into a mixed number, we're going to have 2 and 4/5. We can't really come up with 2 and 4/5 egg. So therefore, we're going to come up with a realistic number that does not involve a fractional part of an egg. And we would say that in order to come up with these 7 dozen cookies, we're instead going to use 3 eggs.